Okay, well, welcome back to this first video of the Quantitative Lab, where we're going to do now a deeper analysis of the data that we have. And maybe, this is just an assumption, it's up to you what you will do actually in your physics, but let's assume that for this practice, I want to check if there is a significant difference between grade and gender. I mean, like, if there is a significant difference on the grade, depending if you are a boy or a girl. So this is one of the most basic from the advanced group of analysis, right? It's not a regression. It is just comparing the means with what we call the t-test. I think that you should also check the video about data analysis on the t-test, but we are going to test if it is possible, if there is a significance between the average grade that you can get, depending if you are a boy or a girl. So to do that, we need to go to analyze, and then we go to compare means. There is a lot of compare means. We have one sample t-test, independent sample t-test, and as I said, I want to compare if it is significant to have a different grade depending on if I am a boy or a girl. So to test that, I need to do an independent sample t-test. And here, well, again, because I already did it before the video, I already have what I want to do. Let's start from 0. So what I want to test is the grade. I want to test if there is significant difference on the grade depending on the gender. So I will put the gender in here. And there is still one thing that I need to define, which I think is found it a bit dumb, but you need to do it manually. You need to define the groups when you have a dummy variable. So you need to define which one is group 1 and which one is group 2. So I will say that group 1 are the ones, the males, and group 2 are the females, 0. So then I click continue, and then you click OK. And then you get this, this result. So first, and I think this is really nice, it shows you the group statistics. So first thing, you can see from the group statistics that the males, not one, have a lower mean, a lower average on their grade compared to women. So the first conclusion is that men and women in this sample have different grades. Like one has 72 and the other one has 75. So women tend, in this case, women have higher grades. But we need to test if that difference is significant or not. So let me show you this table. This table gives me the significance. The computer already did all the calculations. So the first thing that I want to see is if I should care for this or for this line, the equal variances assumed. And we are very lucky that SPSS gives us already the number, so then we can decide. So check if this number over here, the significance of the Levin test, is higher or lower than 0.1. If it is higher, then you have to use equal variance assumed. You have to assume that the variance is equal in both groups. So the significance is higher in this case. So I will assume this, I will use this. If you get a significance lower than 0.1, then you assume this one, okay? But most of the time you will get this because you have equal variances. That's another of the assumptions that you need in order to do a t-test. So I think whenever, if you already have normality and you have the in the dependent variable and you have like a proper variable that you can use to compare with, most of the time you will get this higher than 0.1 because the variances are similar. The next thing that you need to check is if the significance is higher, and usually it is from the two-sided the two-sided p-value. The difference between one-sided p-value and two-sided p-value is if you only care about the higher grades, like the average to the high, then choose one side p, because you only care about one side of the distribution. Or the other way, if you only care about the low grades, like if you want to compare if you want to test for the significance of one side of your distribution, then care only for one-sided p. But if you care, like I think we do, we care if it matters, if your gender matters whether you get a higher or lower grade, pick up the two-sided p-value. If this p-value is higher than if this p-value is lower than 0.1, which usually 0.1 is a good degree of confidence. Again, I am talking a lot on words that you see in the that you saw from the lecture. So remember, if you are not getting me, go to the lectures videos. So if this is lower than 0.1, we can assume that the difference is significant, right? Like it is significant. But since here the difference is 0.554, the p-value, sorry, we conclude that no, the difference that we found in here is not significant in terms of gender. So just say that it is not. And you can see here also, I think we talk a little bit about this in the lecture, that the interval of confidence is super large. So that also gives you a hint. But the important thing is this is what really matters. If this is below 0.1, then you can assume that that it is significant, but because it is not below 0.1, it is not significant. So you conclude that the t-test says that it doesn't, well, that's kind of the main conclusion, that the gender doesn't explain this, is not significant, this difference in the mean of the grade. So that's kind of the first analysis. Very simple, because we only, and remember also from the lectures, this t-test is only with the averages, right? Like it only compares the average of the samples. We are going to do a little bit more complex analysis in the next videos, okay? So let's finish this one here.